I'm Neil Walder for Kit Guru, and today's review is this Gigabyte X470 AORUS Gaming 7 Wi-Fi motherboard. A mouthful of a title, but you do get an awful lot of motherboard for your money, so we can forgive them that. You've actually seen this motherboard before, provided that is you've watched either or both of my videos for the launch of 2nd gen Ryzen 5 and Ryzen 7. I use this motherboard for both of those, and it worked very well indeed. For a CPU launch, really what you're looking for is stability, because you just want repeatable results and no excitement. And this motherboard delivered that absolutely flawlessly. It's an ATX form factor rather than eATX, but there is an awful lot of hardware crammed in. I mean, there's barely any space at all on the PCB. But how about you come in closer and we'll look at the features in more detail. You get a bunch of accessories in the box, some more exciting than others. So, some old school stickery things, not interested in those. Software user guide, introduction guide rather. That's the main user guide. We've got SATA cable, front panel connector, so you connect the case headers and such like to that and then plug it into or on to the front panel. SLI bridge. Wi-Fi antenna rather. There are the two MMX connections which go to the I/O panel in the usual style. Velcro straps for keeping everything tidy. Come to that in a moment. Empty bag. M.2, 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 so spacers and screws. Another SATA cable. And this is the good stuff here, which is RGB. Move that out of the way. Move the board in. So we have two temperature sensors which connect to that connection there and that connection there. That one there is actually so tight between this fan header and the USB connection that it's not actually screen printed on the board, but it is in the manual, so it's there to be found. And here we have two RGB cables. So that is a digital LED cable which goes to that there, which is labelled VDG. So that's a 3-pin header on the board, which then breaks out to a wider 3-pin header at that end. And this is interesting. This is RGBW. So like a snake, it's eating itself at the moment. We've got two RGB headers on board. One there at the top of the board, one there at the foot of the board. So RGB and then 12 volt standard 4-pin. These are 5-pin because the W connection, which is either for pure white or indeed for ultraviolet. So that, let's put it in the top of the board and we'll connect it correctly even though nothing's powered on, just because it feels right. Plug that in like so. And there we go. And now we have a 5-pin connection for the RGBW light strip that you may or may not have, but you don't. You've got a conventional 4-pin. Pop that off the side. I say pop, wrestle it off, and there you go. And now it's a standard RGB header, which is very sensible. I do wish that, as there are two RGBW headers on the board, two cables, not much to ask, is it? I mean, please. I'm sure it adds some cost, but how much cost? And we're going to go and get such a cable at the drop of a hat. Let's just plug that back together, because the pins on these cables are often very, very delicate and want to look after it. And there we have the board itself, and it is a piece of work. So we've got some extensive heat sinks on the VRMs, linked by that heat pipe next to those, and in the angle here we've got a 4-pin and 8-pin power connector. Looks good. As far as I'm concerned, total nonsense. I cannot think anyone is going to require more than an 8-pin connection to power their Ryzen processor. Here we have the I/O panel, which has a fixed shield. I like that a lot. We've seen that previously with the Zeus on the high-end ROG boards. Makes perfect sense. Means you've got to put a piece of tinware into your case and then hook the board into it. I like that. Here we have some memory slots. Now, they may not at the moment look like anything much, but if I take this little USB power pack and hook up this clever little cable here to that point there, and look, everything lights up. I think it's only polite actually if I just turn off the lights. and you can see it in all its glory. Now this is in demo mode, so these colours will cycle and the I/O shield lights will flash, but it is actually entirely and completely controllable in the Gigabyte software, as I'll show you later. This is, as I say, just a demo mode, so it's a USB connection just to power. And there we go, and let's just turn that off. So that is quite impressive. But the software, it's a standard software, so you can control either the whole board, a breathing pattern, flashing, whatever you want to do, rainbow marquee, or indeed you can control it by zones, and indeed you can add in extra lighting strips using the headers and connectors on the bottom and the top of the board to extend the lighting system. Quite impressive going. Moving around, so we've got there are your CPU fan connectors. Here we have the memory slots. There we have an OC button. That is one of the most forgettable features of this motherboard, because it basically allows you to click the button and bump, you have a preset profile for your processor, but the thing doesn't tell you what's going on. So I used that on my Ryzen 7 2700X, and it appeared to bump the speed up to 4.0 gigahertz using 1.35 volts, which is utterly pointless. But it's not a toggle button, it doesn't kind of light up, it doesn't tell you what's going on, the BIOS doesn't, pointless, just forget it even exists. 24-pin main connector, 3 PWM fan headers there, postcode debug, BIOS switches, because this is a dual BIOS board. There's the one BIOS. Here under this little cover is the other BIOS, so that's actually socketed. So if you hit some sort of terrible problem with your board, there is the outside chance that Gigabyte might actually send you a new BIOS chip to replace it, rather than having to send the board off for RMA. Have to see whether that actually happens, but in theory it's possible. And just across from that, another 4-pin PWM fan header. We have a USB 3.1 Gen 2 connection, like it. Here we have some armoured PCI Express graphics slots. There we have a full length, but obviously not ×16 slot. And we have some ×1s. These M.2 slot covers rattle. That's annoying. Why on earth they haven't done something about that, putting an O-ring under the screw or some such, I do not understand. That, silly and annoying. Here we have the SATA 6 gigabit connections. Here we have the front panel headers. USB 3.0s in my book, or if you prefer USB 3.1 Gen 1s, take your pick. A couple more fan headers again for pins, some USB 2s, TPM header, we don't care about that. Lighting connection as previously mentioned, audio connection. Here we have the caps for the audio. All really good stuff. There is almost nothing to dislike. The OC button I could do without, but that's about it, and those rattly covers. So far, really good news. And then we come to the I/O, which is also good. So, curious, power button and BIOS reset are on the I/O. Have you ever seen that before? Personally, I don't think I have. Presumably it's because Gigabyte doesn't have the space on the board to install the buttons elsewhere. On the one hand, this means you don't have to remove a side panel from the case to access those buttons. On the other hand, might you reach around the back of the case for a cable and accidentally turn the power off or hit the reset on the BIOS? I can imagine you might. So I'm not clear that that's a good idea. I'm going to say for the moment, interesting, not sure. Connection points for the 8211AC Wi-Fi, which is Wave 2, therefore very fast. You can't see it, but inside we've also got Bluetooth 5. Here we have USB 3.0s or 3.1 Gen 1s if you must. USB 3.1 Gen 2s, a Type A, Type C. That's some USB 2, that's Gigabit Ethernet, that's USB 3s, albeit yellow for audio, and there we have audio connections. Loads of good stuff. Really good list of features that just gladden the heart and make you go, yeah! What would you change? Would you change anything on this board? I don't think you would. That is pretty much just peachy. With the shroud removed from the I/O and the M.2 covers removed there, you can see far more of the VRM hardware, and here we have the heat sinks, which is a fully finned array. Fun enough, that fin on the end there that's missing, when I was doing my launch review of Ryzen 7 or Ryzen 5, I forget which, and I used the stock AMD cooler, which had a flip lever, would have been the Ryzen 5. It was really highly tensioned. And when the lever finally pinged free, that last fin flew off, and I have no idea where it went. So that tells us something, I'm not quite sure what. Anyway, the heat sinks look good. Loads of surface area, heat pipe joining them together, thermal pads as you'd expect, and underneath we have the hardware. which consists of a 10+2 setup from International Rectifier. These are 3553s, they're 40 amp stages, and then we have some 3556s here for the SoC, which are 50 amp stages. There's a doubling scheme going on, which means that the VRMs are addressed in pairs, but that does not make the blindest bit of difference to how the whole thing functions, because either the VRMs themselves or the Eaton conductors or the heatsinks or some aspect of the hardware means they run really cool. I am fairly confident it's actually the VRMs themselves. The heatsink is doing its work, but it's not sitting there glowing warm. The VRMs under load will be below 55 degrees Celsius during my testing, and that was overclocked. Basically, they're idle at 40, they go up to 50 something under full load, whereas the ASRock X470 Tai Chi I recently reviewed, that would be around 70 degrees. So this hardware, really good. The layout is neat and tidy, and the layout of the VRMs and the arrangement is of a piece with the rest of the board. Really, really good. Our test system consists of an AMD Ryzen 7 2700X. We've got as a CPU cooler the Fractal Design Celsius S24, that's a 240mm Ace Tech. We've got some G-Skill Sniper X DDR4 3400 MHz memory, dual channel, EVGA GTX 1080 Ti graphics card, and the power supply is a Seasonic Prime Titanium 1000 watt. Around here we have a SATA SK Hynix SSD. It's time to take a tour of the BIOS. If you watched my review of the second gen Ryzens when we did the launch of those, you will have seen a very similar BIOS setup. The BIOS has actually been updated since then. We're now on version F4E, but it looks exactly the same to my eyes. It's sort of memory support and so on that's been updated all in the background. The look and feel of the BIOS is the same as before. System information just gives you, date, time, and the BIOS version, name of the motherboard, nothing special. Go to MIT, so advanced frequency settings. Easy overclock tuner is a little bit deceptive. It doesn't say allow you just to punch in, 4.3 gigahertz or call up a stored profile. Instead, you basically pick a memory speed, and the system will then give you that memory timing based on combination of base clock and multiplier. Really not that interesting. XMP works nicely for us, and really with an AMD system, memory support is fraught. So anything that's not XMP, you're really making life difficult for yourself, in my opinion. CPU clock controls, that's the base clock 100 megahertz. If you want to start tickling that up to 101, 102, 103, fair enough. Personally, I do not. CPU clock ratio, so we'll go for 42.5, 4.25 gigahertz in other words. Advanced CPU core settings, so that's things like turning off cool and quiet and such like, or disabling SMT. Not going to touch any of that. XMP is already enabled. We've only got off or profile 1. After all, XMP is an Intel technology. With some Intel boards you'll sometimes get 2 XMP profiles. With AMD you get 1. The Sniper X from G-Skill runs at 3400 MHz. Happy, that's all I require. If we come out of that, go into advanced memory settings, so here we have the breakdown of what's involved. If you want to start tightening up the timings, we know there's benefit to be gained there, but XMP out of the box does a fairly reasonable job. Advanced voltage settings, not a huge amount to see here, so CPU V-core, if we punch in 1.4, if we go down, I'll leave the V-core SoC alone. Again, you can tickle that up to 1.15, maybe 1.2. Then we come down to load line calibration. As I cycle up through that, so auto, normal, standard, low, medium, high, turbo, and extreme, and that's the limit. So come back 1 to turbo. Same for the SoC load line calibration, turbo again. Come back. PC health status gives you the various voltages. Miscellaneous settings, not a lot to see there. Smart fan 5. Gigabyte's done quite a lot of work on fan control in recent years. This all works well. I think historically it'd be fair to say that Asus had a reputation for doing really good work with fans. I would say Gigabyte is also up there and fighting. Elsewhere in the go across the BIOS tab, we've got boot options. Peripherals, not a lot to see there. It's audio networking and such like, as you'd expect. Chipset basically at SATA and NVMe. And then we save, and the system reboots, and it'll reboot running at 4.25 gigahertz on all cores. It's been absolutely stable at that clock speed. As to what benefit you gain, that's a different question. We'll come to that. But anything more than 4.25 with this CPU, this Ryzen 7 2700X, I've had no joy whatsoever. I can push it to 4.3, run a benchmark, and it'll free solid. Having said that, I've not taken it beyond 1.4 volts. I'm really not that interested in running it to 1.45 or even 1.5, God help it. It just doesn't seem worth it. And there we have it, CPU IDHW monitor, all cores 4.25 gigahertz, and it's stable at that speed, no problem whatsoever, runs the benchmarks quite nicely. And just to demonstrate the overclocked Ryzen 7 2700X in action, we have Cinebench. So the stock processor runs at 1800 odd marks, and the fans kick up. And this overclock processor is going to be 1900 because it's always 1900. $1924. As regular and predictable as a watch. And that's 4.25 gigahertz, as I said. And we also have some software. Now you have to use this Gigabyte AORUS App Center to install the various bits of software you want to use this motherboard, which realistically is the Fusion lighting software. AppBIOS is their utility that allows you to update the BIOS from within Windows. It works perfectly well, but then again, downloading a BIOS, sticking a flash drive and going into the BIOS setup, it's not that difficult either. USB blocker, cloud station server, fast boot, on-off charge 2, SIV is system information viewer, that's all right actually. Smart keyboard, smart time lock, loss of smart backup VTuner. What the heck's VTuner? Allows you to easily fine tune your graphics card. Well, I think we use the graphics card software that comes with the graphics card, don't we? Or yes, I don't think we're there. Anyway. 3D OSD, utility to help gamers to show FSP. I mean, this is all stuff where you're going to have your own favoured software. The idea that this software is going to leap off the page at you, I very much doubt. What else? Game Boost, BIOS setup, Chrome. I mean, this is the sort of thing that starts to actually bug me at this stage. Google Toolbar for Internet Explorer. Internet Explorer? Some of those utilities might appeal to you, but once you get to this stage, third-party software, so Google Chrome, we don't need a motherboard manufacturer to push Chrome at us. Google Toolbar for Internet Explorer. I mean, really? And besides, isn't it called Edge these days? Norton Internet Security. I'm guessing you have your view on that one. No, not impressed. And within the App Center, I've got two pieces of software installed. I only use one of them as it happens. So we've got EasyTune, which is an overclock utility that works within Windows. Not my preferred way of doing things. I much prefer, if I'm going to do that, to work in the UEFI. But nonetheless, here we go. So there you've got system information. There you've got the CPU overclock and DDR4, advanced power. That's it. But as I say, I'd much rather change that sort of thing in the UEFI. And then RGB Fusion is exactly what you'd expect. So you've got a bunch of presets, pulse, music, color cycle, demo and such like. If you want to go down the slightly more advanced route, you pick a zone on the motherboard to tell it what you want to do. Intelligent is quite cutesy, so you can, for example, have the lighting reflecting CPU load or CPU temperature. But again, what do you really want? Do you want your lighting system to kind of change colour to let you know that there's CPU's getting rather hot, or would you rather have your fans kick up and go faster? I think I know which I'd prefer. So I prefer to use the lighting just frankly for fun rather than as a diagnostic tool. Where have I got it? Here's this RGB strip which is plugged into the foot of the board. Feed that up there so it's in view. And if we go for demo, and the whole board is now going through a colour cycle, just as you'd expect. And now it's doing a random thing. They all look fun in games, these various profiles. I must confess, either static or pulse would suit me quite nicely. This is the sort of thing that would look good for about 30 seconds and then not so much. But fair enough. It's a solid motherboard. The lighting is quite clearly the bells and whistles on top. And I have to say, Gigabyte's actually done a very good job with the lighting. If RGB is your thing, this motherboard, it gives you what you want. That's absolutely for sure. To wrap this up, there is a huge amount to admire about the Gigabyte X470 AORUS Gaming 7 Wi-Fi and not very much to dislike. So I'll do the cons first and I'll finish on the pros. Let's have an upbeat theme here and a feel, because this board deserves it. On the negative side of things, and we're talking trivial stuff, so the M.2 covers, they rattle. O-rings under the heads of the screws or some sort of packing piece or something will fix that. It would be a shame to remove the covers to prevent the rattling, because they look quite good. They fit in with the theme of the board. So that is a thing. I don't like it, and it would have been easy to fix, and I'm surprised that someone didn't pick up on that during development. Such is life. Buttons. The OC button there, I prefer not to have it. There's no explanation as to how it works or what exactly it does. And it doesn't really seem like it's an on and off thing. You kind of press it and you go, well, what's happened? So I prefer not to have that. The power button on the I/O panel, and indeed the clear CMOS buttons. Now, in principle, they're quite a neat idea, because it's obviously easier to reach to the I/O than it is to take the side panel off your case and go inside to stab a button in the event you've got some sort of problem. But I can imagine myself reaching around the back of my PC when it's built. There's the front, there's the back, this is in the dark corner. I want to reach in and get a Bluetooth dongle or something, or a cable. It's got Bluetooth built in, won't need a Bluetooth dongle. A cable of some description, stabbing a button in error, causing a problem. If you could lock those buttons out, that would be fine, but as things stand, I'm not sure. It's not a problem as such. I can just see it being, you know, a snag on occasion to some people. So that's different. Whether it's a winner or loser, I'm really not sure. I'm going to list it as a con because I just do not know for sure. The UEFI, going back to the OC button, is uninspired, but this seems to be the way with AMD UEFI stroke BIOS support. You don't get the thing that you might want, which is a set of overclocking profiles. You go in and you go, I'll choose the 4.1 gigahertz profile, thank you, 1.35 volts, click, bang, job done. That would be useful. We've seen that with Coffee Lake on some motherboards. It generally works quite well. If you want to go down the manual route, obviously that's fine. But a profile that is obvious, that is just straightforward, that's what I want to see. Most of the features in the UEFI, you just don't require them. So I want them. I want to know they're there, but I probably won't want to use them. So give me the basics, give me the overclocking profiles, let me have the advanced stuff just in case I need to do it, but I probably don't. That's a general criticism of UEFIs for AMD, which is that they don't seem to particularly do anything out of the ordinary, and neither do they quite offer all the features that I want. Having said that, they work, the UEFI on this board works, it's just meh. And then we get to the good stuff, and there is a lot of good stuff. The build quality is excellent, the VRMs, the heatsinks on the VRMs works very well, the fixed I/O shield I like, the slots, the metal support on the slots, very good. Headers and connectors like you would not believe. The RGB, I mean, you can turn the RGB off if you don't want it. You can turn it on and you've got just a light show. Works absolutely superbly well. There's nothing to dislike. There is actually nothing to dislike about the layout other than those buttons that I've already mentioned. But that is surely because Gigabyte's crammed an E80X board into an ATX form factor, and there really just is not the space for everything that they want. So they've put the buttons on the outside, for example. But it's a really good job, really deeply impressed. And in terms of value for money, wow, yes, you get a huge amount for your money, and this board just knocks it out of the park. Truly impressed, really good news. If you like this video, thumbs up. If you don't, thumbs down. If you want more from KitGuru, click to subscribe. Hit the bell button, you'll be alerted to new videos from KitGuru as they become available. I'm Leo Woodard for KitGuru. This is the Gigabyte X470 AORUS Gaming 7 Wi-Fi